Hello, everyone. I hope you're doing well today. For those who just arrived, please feel free to type in your name in the chat box, where you're from, and what company, university, or organization you're representing. Welcome to you all. I hope you're having a great week so far. I am Emily from SuperMap, and I would like to acknowledge our host university, the National University Center for Innovation and Entrepreneurship. Say hi in our chat box, please, students and faculty of NU. And to everyone here, it is my pleasure to welcome you to this webinar entitled SuperMap GIS Solutions for Telecommunications. To jumpstart our event for today, let us hear some opening remarks from Sir Christian Aldwin D. Canlapan, UIEC of the Center for Innovation and Entrepreneurship in the National University.
Hello, good morning.
Hello, good morning.
Can you hear me po? Hello.
Yes po, Sir Christian.
Good morning, SuperMap GIS participants and colleagues that join us here today. Thank you for coming to this event. This demonstration would introduce us to the technology of Geographic Information System. It will help us to understand how does it works. Kindly pay attention and participate in the Q&A later. We hope that you will be able to learn and realize the possibilities and application this geographic information system could bring to your current plans and endeavors. SuperMap, thank you for holding this type of event and for inviting our community to have a walkthrough with your technology and what you could offer. For the sake of advancing the research and innovation, the NU Center for Innovation and Entrepreneurship is glad to co-host this event. On behalf of Dr. Ria Lisa Canlas, our Director in CENTI, we are welcoming you to this webinar titled SuperMap GIS Solutions for Telecommunications. Thank you.
Thank you so much for that warm welcome, Sir Christian. Moving on to the topics for today's webinar, we're going to have two presentations. If you have any questions while listening to the speakers, please feel free to type it in the chat box below. The technical team will answer the questions in the Q&A session after the presentations. Our first topic is on the introduction to SuperMap GIS technology, to be presented by Erica David from the Business Development Team of SuperMap Asia and Oceania Center.
Good morning, everyone. I am Erica from the Business Development Team of SuperMap here in the Philippines. For my presentation, I'm going to introduce to you our company and the key technologies that help SuperMap to provide solutions to different industries, including telecommunications. So let us start with a brief company background. SuperMap was founded in 1997 by Dr. Ershan Zhang, and with that, we now have almost 24 years of experience in the GIS field. SuperMap is headquartered in Beijing with 38 branches and offices in mainland China, Hong Kong, and Japan. As of now, we have over 4,000 employees. And we are happy to announce that we have some job opportunities available for you. Should you be interested, just visit our Facebook page at SuperMapPH or email us at supermap.ph@gmail.com. This is the China GIS market share in 2015. We can see from this chart that SuperMap is the top 1 GIS software provider in China since 2015. And also last 2019, SuperMap was able to climb as the top 1 in Asia. Shown here is the SuperMap partnership map. As you can see, SuperMap has already been promoted in the market of South Korea, Indonesia, Malaysia, South Africa, and also some countries in Europe. To date, SuperMap has about more than 700 partners from all over the world. Some of them you might already be familiar with: IBM, Microsoft, Huawei, among others. SuperMap has also entered the Philippine market and our business is still expanding. Connect with us through the emails that you see on your screen. Now, we move on to the key technologies of SuperMap, which we call BitDC, Big Data GIS, AI GIS, Distributed GIS, and Cross-Platform GIS. These features are the main advantage of SuperMap. I'll be introducing them to you one by one, and we're going to start with Cross-Platform GIS. Cross-platform GIS is easy to understand. This means that our GIS products can run both in Windows and Linux natively, not only on the server side but also on the terminal side. Next, we move to the distributed GIS. The distributed GIS mainly have these 5 technologies. They are the Cloud Native GIS, SGIS, Distributed Spatial Analysis and Processing, Distributed Spatial Data Engine, and GeoBlockchain. Distributed Spatial Analysis and Processing and Distributed Spatial Data Engine are related to the big data technology. The GeoBlockchain is one of the new features that we released on the newest version of our product, which integrates a blockchain technology to enhance the GIS capability. And the Cloud Native GIS and SGIS are both related to the Cloud GIS. Here, I listed all of the SuperMap GIS distributed spatial data engines such as HDFS and DFS. These two are the distributed file system. And for SQL spatial database, we also support the big data technologies such as the Oracle RAC, SQL Server Cluster, Postgres SQL, and others. And for the NoSQL, we support HBase, MongoDB, and Elasticsearch. We use all these spatial data engines to cover all the spatial data that we have, including the vector data, raster data, images, and 3D model data. Next, we integrated blockchain with GIS, resulting to GeoBlockchain. Blockchain is a special data storage method with the following features: safety, traceability, and credibility. Distributed spatial analysis and processing is about dividing a single complex task into multiple tasks, such as if you have multiple servers cooperating with each other as a cluster. It allows multiple computers to work separately at the same time, then merge the results. In this way, we can greatly improve the processing performance. Next is Cloud Native GIS. The traditional web GIS architecture is a single framework. The crash of a certain module could cause the crash of the whole system. We divide the GIS server software into several modules, and they can run independently in different containers. These containers can then be deployed on different computers. This brings 2 features. The first one is highly elastic. If a module has a lot of requests, we only need to start more instances of this module instead of the whole GIS server. Another one is fault isolation. The modules are independent. Even if a module crashed, others will not be affected. Then last is SGIS. In the framework of classic cloud computing, it takes a long time of network latency when the terminal is accessing the cloud directly. So we deploy edge servers near to the terminals to process the request and reduce the network latency and improve the performance of the whole system. We now proceed to the next key technology of BitDC, Big Data GIS. This has been a popular technology over the recent years. SuperMap is highly capable to do big data storage management, big data analysis, streaming data processing, and big data visualization. SuperMap presents a high-performance GIS computing model integrating kernel computing and distributed computing. Spark is fused, and the multi-level and multi-granularity distributed computing framework of Big Data GIS is constructed. This improves the performance of GIS core analysis by an order of magnitude and significantly reduces application threshold of GIS core algorithm under the big data environment. Currently, SuperMap supports a variety of distributed operators, including spatial big data, streaming data, and spatial machine learning data. The new big data analysis operator is mainly used to process and analyze new types of data, such as IT big data, including reconstruct tracks, summarize with grid, summarize attributes, summarize with region, calculate OD matrix, find hotspots, calculate density, detect incidents, search similar locations, join features, spatial filter, attribute filter, build multivariable grid, resident analysis, and many more. Shown here is sample of one popular algorithm. This is a hotspot analysis to monitor urban operation in real time. This is another example of big data analysis in COVID-19 big data decision system. This platform allows hotspot analysis to visualize the intensity of COVID-19 patients in a specific area. It can also create a trajectory map of the data. We have more spatial big data anal- analysis operators such as population boundary analysis. We have residential space analysis, including spatial structure analysis, public center system, and service scope analysis. Traffic facilities analysis, including road congestion analysis, public transport convenience, and service scope analysis. We also have corridor and work-living balance analysis. This is the example of static rendering visualization of geographic data. It supports grid map, OD map, road map, and other static geographical visualization. From static visualization to dynamic visualization, it also supports the visualization of dynamic data such as strong boundary map, dynamic OD diagram, trajectory map, and so on. And these are the examples of advanced visualization of geographic data. You can see that the effect is very cool. We can display this advanced visualization both in 2D or in 3D data. So that's all for the big data technology. We now go to the AI GIS. This shows all the operators we can support with GeoAI, such as classifier, cluster analysis, spatiotemporal analysis, 3D analysis, and image analysis. Based on these operators, we can do object detection, such as the one shown on your screen, detecting palm trees and getting the number of trees. Another sample is predicting the real estate price data in the city based on forest regression model with transportation, education, medical service, and other infrastructure based on space as variables. And also detecting damaged roads. We can see that with just pure training model, we can automatically find the cracks on the road. This is a case of traffic flow prediction based on graphic neural network. We model the sensor devices all over the road as the nodes and the distances as edges using 4 months of historical data for training. SuperMap predicted the traffic flow in the next hour at 5-minute intervals. The best approximation can reach 92.7 prediction accuracy. Using iTablet, we can also identify and collect attributes and geospatial data. Just by pointing the camera, we can identify objects and see their information. We can also beautify maps with AI to color matching and style migration. We can adjust color image, brightness, contrast, and saturation. This is a sample where GIS provides value for AI outputs. This is geofence violation monitoring, where the polygons are set as the fence in recognizing real-time violations of vehicles. The last technology I'm going to introduce to you today is 3D GIS. We are confident to say that SuperMap 3D GIS is the most advanced one over the world. As you can see here, the new 3D GIS applications is divided into four main parts, beginning with the 2D and 3D integration model, containing the several types of data models such as the 3D points, 2D network, TIM, TIN, voxel grid, and grid. The second part is the 2D and 3D integration technologies. We are not only aiming to display 2D and 3D data separately, but integrating both of these data. And also we're capable to consume different types of data like oblique photogrammetry data, BIM, point cloud, 3D field, and others. And after we import it in our software, we can give an output in various formats and iterations by using VR, AR, WebGL, and also 3D printing. So let us start with 2D and 3D integration model. SuperMap is capable of handling different types of data models of 2D and 3D, from object models containing points, lines, and polygons to field models in visualizing continuous surfaces and 3D spaces, TIN and grid for surfaces, and TIM and voxel grid for 3D. You can also generate network models both in 2D and 3D. We can show the underground geographical body. And with voxel grid, we can express the analysis of sunshine rate, which is useful for urban planning. And we can also attach to the surface of the building. This is the simulation of communication signal. So this can be used in the telecom industry. Next is 2D and 3D analysis. We can do skyline analysis and also visibility analysis to see which are visible from a viewpoint. We can also see the underground view together with the surface models at the same time on the same platform. And we can also show the different sections of a building. Next is multi-source 3D data integration. In SuperMap, we can support all 3D model data such as terrain data, oblique photography model, building information model, field data, pipeline data, point cloud, water body, fine models, and geobodies. So after showing you how SuperMap integrates 2D and 3D data and the various data models and sources that we can integrate to create a 3D digital space, I am now going to show you how SuperMap is able to improve the various ways that we can interact with 3D. With the continuous progress of large-scale 3D spatial data collecting technologies, 3D spatial data formats are also increasing, such as 3D tile on the Seashore platform, OSGB on the OpenScene Graph platform, and 3MX on the Bentley platform. So the majority of users should have a deep understanding of the inconvenience of conversion between different formats and different version on different platforms. Therefore, the efficient 3D spatial data release, sharing, and interoperation in the industry has always been an issue for the entire geographic information industry. Faced with these problems, a unified and open 3D data format is greatly needed in the industry. The open and extensible 3D geospatial data format, Spatial 3D Model S3M, can provide specifications for the data format for the transmission, exchange, and sharing of spatial 3D model data between different terminals. S3M solves the problem of multi-source heterogeneous data and provides standardized data format and can be adapted to various forms of user applications such as virtual reality, augmented reality, PC, web, and mobile. We also combine GIS with game engines such as Unity and Unreal. 3D GIS will give the game capability for large-scale 3D data management and GIS analysis functions. On the other hand, using game engine gives better rendering effect to 3D GIS. So here is a sample showing how game engine improves the rendering and visualization of 3D data. This is a game scene of Unity. All the terrain and buildings data are oblique photogrammetry 3D data managed by SuperMap. So to recall, the SuperMap GIS 10i technology system summarized as BitDC consists of Big Data GIS, AI GIS, 3D GIS, Distributed GIS, and Cross-Platform GIS. So this is our product system provided by SuperMap. They can be divided into three parts: the cloud side, edge side, and terminal side. On the cloud side, we have the iServer as the server application to publish our spatial data and GIS capability. The iPortal help us to easily create our GIS portal. iManager is for operation and maintenance. On the edge side, we have the iEdge, which can help us enhance performance when the network is not good. On the terminal side, we have the Terminal GIS for desktop, the iDesktop, and iDesktop X. The Terminal GIS for components, they are objects for different coding languages such as C++, Python, and Java. And also for new technology for blockchain and Scene SDKs for game engine. Then we have the iMobile and iTablet. And under web, we have the iClient for JavaScript, mainly for 2D and WebGL for 3D. So that's all for my presentation. Thank you for listening.
Thank you so much, Erica. Pretty cool, right? That was just a sneak peek of the applications that can be done with the DC technology of SuperMap. While you're letting all of that sink in, maybe you can also start wondering on how you can utilize this kind of technology in your field or industry. We're excited to hear about what you come up with, and we're very open to collaborating with you to make that happen. Again, if you have questions about what Erica just presented, anything about the BitDC technology of SuperMap, please head to the Q&A chat box below and our technical team will answer them. At this point, we will have a quick 3-minute break. So meanwhile, kindly fill up the form that you see on your screens right now for your certificates. They will also be linked in the chat box below, so you can generate your e-certificates for this event. Take note that the form will only be open until the end of this webinar. Now heading on to our second and last topic, Ian Almazan from the Business Development Team from the Technical Team of SuperMap Asia and Oceania Center will be presenting to us about SuperMap's telecommunication solutions. So you now have the stage, Ian.
So, good morning. Welcome to this presentation of SuperMap Telecommunications Solutions. Telecommunications has revolutionized the lifestyle of the population today. The technologies and services it offers are necessities for most of us in the 21st century, just as much as electricity, tap water, and other usual utilities. Even more so in these trying times of isolation due to the coronavirus pandemic. We use it every day, or maybe more appropriately, we need it every day. We need it to talk to the people we like, such as our family and friends. We also need it to do things we enjoy, such as watching videos, viewing our needs, and generally staying updated on things we care about on the internet. We also need it to do other slightly less enjoyable but just as necessary things, like our jobs, talking to our bosses and teammates, making Google searches, watching our cryptocurrency investments dwindle, or enrolling and taking part in online classes and online webinars. We have even started using it to do the basic tasks needed to live, such as buying our food, paying our bills, and managing our money. The point is that our use of telecommunications is probably just as big a part of our lives as any other. From the wired telephones of the 80s to the first cellular phones in the 2000s, and to the smartphones constantly attached to us today. Our need for it has increased year after year, and our demand for efficiency and service from our providers increases with it. So consider this map from Globe Telecoms showing the type of signal or service available for different areas in the Philippines. It can be observed from this map that we now have 5G for the main capital cities in the country, such as Manila and Cebu, and at least 4G in the majority of other areas. This is fascinating when we take it with the context that just some years ago, the 4G that is widely available now was considered something new for us to enjoy. Furthermore, maybe some of us can still remember the old days when we were limited to texting and calling on our phones. And when accessing the internet, using our phones was not something that we take for granted. And even now, we crave for faster internet speeds, better service, and even more efficiency from our telecommunication. This just illustrates that telecommunication is and has been one of the fastest growing technologies as demanded by the needs of the modern population. With the rapid development and innovation in telecommunications comes the need for the solutions to support these developments and innovations. This is where GIS and SuperMap comes in. We provide telecommunication solutions that allow our telecommunication providers to manage their resources and services in order to keep up with the ever-rising demands. GIS powers telecommunication providers in several ways. In order to be competitive and efficient, telecommunication providers need a smooth and streamlined workflow. GIS achieves this by providing powerful tools for data collection, data analysis, resource management, business management, and a lot of other purposes. In SuperMap, we also provide tried and tested workflows to maximize the efficiency of using these GIS tools and also maximize the benefits for the providers. GIS is also very adaptive and capable of supporting all sorts of workflows and work practices. Different companies in the telecommunication industry usually have different practices and preferences in how they gather or store their data, in how they plan to achieve their business goals, and in how they provide services to their clients. However, all companies generally have the same needs in terms of information and the same resources in need of management. GIS has been proven to be able to adapt to these different practices, as shown in the wide use of the technology by a large portion of the telecommunications industry around the world. One of the main pros of GIS is its powerful query and analysis. These are used to handle the large amounts of spatial and non-spatial data that telecommunications providers need to analyze and organize. From planning the location and architecture of necessary infrastructure to mapping and organizing the different customers or users. These can all be done with GIS, which is why GIS is heavily used in the industry for resource management, network optimization, sales and marketing, emergency service planning, and lots of other aspects. Now, this is the system development roadmap used by SuperMap for our telecommunication solutions. We start with the data on hand or the data to be gathered. This includes both spatial data and business data, which are stored in their respective databases. Spatial data includes the locations and geometries, usually includes locations and geometries in the database. So it may include your pipe and wire networks, your base stations, the terrain, the land use, the buildings, population, and others. Well, the business data includes data on customers, the revenue models, business expenses, and others. These databases are then accessed by the data access engine. For this, SuperMap uses the SuperMap SDX Plus data engine to ensure the proper unity and sharing of data. This engine is then responsible for communicating and taking the necessary data from the existing databases and communicating them to the servers. This now takes us to the SuperMap iServer and SuperMap iClient platforms, which were developed using the C language. iServer, as the name implies, is the local server that you have if you use SuperMap. It handles the necessary data to be used by the GIS system. iClient, on the other hand, is the general development platform of SuperMap. It is used to develop the user interface, the display of the data, and other applications or tools which may be used for analysis of the data. Lastly, after going through iServer and the tools developed by iClient, we get the Telecom GIS environment. This is the GIS environment that has all the necessary data that is needed by the end user, as well as the tools needed by the end user to do analysis and other tasks required for management and maintenance in telecommunications. And here we have a sample database structure that was used for telecommunication resource management. The database divided into several subgroups based on the type of resource or data. As you can see, we have a subgroup for process management, professional resources, physical resources, region resources, system configuration, graphical presentation, and management assistance. These subgroups represent data for different aspects of managing a telecommunications provider. Data or tables for the data in the same subgroup would share a lot of the same attributes and functions among them to facilitate specific kinds of analysis specific to that subgroup. For example, all the data in the physical resources would have geometries describing their locations and shapes, as well as functions and to analyze these spatial characteristics. The functions and analysis applied to these subgroups are done to make inferences and observations specific to the kind of data in the subgroup. Or it can also be done to enable relation of data or tables from different subgroups, which is needed for more sophisticated analysis of data. As effective management of resources requires the relation and consideration of all these different kinds of data. We need to make sure that the moves we make and the steps we take are sound from a physical resource management perspective, from a customer perspective, from a business perspective, and any other necessary perspective that needs to be considered. So, as with the integration of any new technology, data migration from a current platform to the next is important. Before GIS, a platform called CableCAD was popularly used in the telecommunications industry. This diagram shows a schematic representation of the data migration from CableCAD to GIS. The first part is the system development stage of the GIS system. This involves synchronous data loading and data processing alongside the existing CableCAD system. This stage calibrates the GIS system to adapt to the needs of the user. As mentioned before, different companies have different practices and preferences. And this is the stage where we adapt the GIS system to fit those company preferences and make sure that the GIS system accordingly provides efficient tools and streamlined workflows. Next is system test running. This is a dry run or test run of the GIS system on an actual project or problem. The results from the GIS system are compared to the results from the existing CableCAD system and checked accordingly. Efficiency is also assessed to compare gains and losses from the shift to a GIS system. And the last part is the full turnover from the CableCAD system to the new GIS system. The CableCAD system stops running and finally turns over all work to the now officially running GIS system. And here are now the GIS solutions for telecommunications that we will be discussing today. Resource management, network planning and optimization, marketing and sales, failure positioning, location-based services, and emergency services. So now we are in part 2 of the presentation, SuperMap solutions for telecommunications, where we will be showing you the specific GIS solutions for the previously mentioned aspects of telecommunications. So the first set of solutions will be for resource management. Resource management is the foundation of all workflows. It is the most important aspect and covers the bulk of the work of the GIS system in telecommunications. First, we will discuss the type of resources involved in the resource management. The first type is the physical resources. These resources include spatial resources and network resources. Physical resources, as the name suggests, are resources with physical form. This means that they have a location and shape or geometry. These resources can therefore be described using their spatial attributes in a GIS environment. The first type is spatial resources. This includes your base stations, utility posts, regions, and other resources that can be represented in the classical points, lines, and region data types of GIS. Network resources, on the other hand, are special kinds of physical resources that are best represented as a series of nodes and lines. This is usually referred to as a network database in GIS and have a special analysis specifically tailored for them. Examples of these are pipe networks and power line networks. The photo shown here is a pipe concatenation map showing a pipeline network together with the result of some network analysis. With such functions, we can more easily construct and design or maintain a telecommunication pipe network. The other type of resources are logical resources. These resources have no physical form and are purely made up of data. Examples of this are data from customers and from devices using the telecommunications service. This data type is represented as database tables in the GIS environment and can be related to the spatial data via the database strings and related functions of GIS. Shown here is a topology map showing which resources are connected to each other via the connecting lines. Connected devices share a certain logical relation between their attributes. A good management of resources requires the consideration of both these data types. Now, these are the advantages of using a GIS system for resource management. First is powerful management. GIS is a powerful management system mainly because it can manage all the data types involved in resource management in a single system. As discussed in the types of resources involved, both the spatial and logical resources can be managed with GIS. We can symbolize and display spatial data in space while performing queries, analysis, and relates to their corresponding attribute data with logical data. The next is concurrency control. This basically means that GIS databases will contain the data and can entertain multiple and simultaneous user access. This is especially helpful when working with a team or even with your customers. With concurrency control, different team members do not have the problem of conflicting copies of data. And with customers, it provides a better understanding since you can view the same data in real time. This also contributes to the efficiency of workflows and data storage. This concurrency control comes hand in hand with authority. While concurrency control allows for multiple simultaneous use of data, authority control regulates this by setting the types and privileges per user when accessing data. Users are assigned specific credentials and corresponding privileges. Users are allowed a number of privileges which can be to add, edit, delete, manipulate, copy, or move data. This allows for data access without the fear of data corruption, editing, or unauthorized duplication from unauthorized users. This is key in data security and logging changes in spatial data. Logs can be kept on which users perform certain tasks on the dataset at a specific time and date. Keeping backups of data is also greatly helped by this. Lastly, GIS is very user-friendly. GIS software are easy to learn and have a bevy of very good educational content on the internet. GIS workflows can also be customized and optimized to be more streamlined and easy to use depending on the need. SuperMap comes with its own development platform, which allows us to create custom tools and workflows. Now, let us begin introducing the different features of resource management in the GIS system. First is data input. In GIS, we can input both the spatial information and attribute information. The spatial information represents the location and physical form of the object. This can be as simple as points or lines or polygons, or as sophisticated as 3D models or BIM models. Attribute data can also be input together with the spatial data. This adds additional descriptions to the object or resource being described and can be the device number, the address, date of construction, or any other detail. Query and statistics. These are some of the most prominent and most powerful functions of GIS. Queries are used to answer questions based on spatial or attribute relation of data. It can answer questions as simple as which of these pipes coincide with a road or other pipelines, or which pipes have received maintenance within the last 5 years, to other more sophisticated questions that require more analysis, such as which of the planned pipe locations are within profitable areas, while at the same time being outside of high-risk areas. Statistics, on the other hand, show insights from the data that can be useful for decision-making and answering important questions. Some questions that can be answered by statistics are what percentage of pipes fail when subjected under certain conditions to a certain location. The illustration here is a GIS application specifically made for the query and statistics of optical cables. The bar chart and the pie chart shows statistics regarding the use and conditions of the selected optical cable. The pie chart shows the load of the optical cable, and the bar chart shows the lengths of these cables in different cities. A schematic diagram of the cross-section of the optical cable is also shown for an intuitive display of the data. The blue circles represent the primary level optical cable lines, while the green circles represent the secondary optical cable lines. These are applications developed in the GIS system to make a more efficient and more user-friendly workflow for the management of optical cables. Next, we have circuit scheduling, which is about scheduling the opening, closing, and maintenance of your circuits. All the necessary details can be viewed in a table in the GIS environment. Each item has data on which personnel or company is responsible for the activity, and which circuit is the subject of the activity, the reason for this, or why it will be performed, and what kind of specific activity will be done, or whether the circuit will be open or closed, and the exact time and date of the activity. This table is used to check conflicts of schedule and organize the schedule accordingly to maximize your productivity and prevent unwanted problems arising due to these activities. Certain kinds of analysis can also be done on the data to identify the optimal times and dates for each activity, depending on the set goals or parameters of the analysis. Data management is mostly concerned with data security. In a GIS system, this is achieved through assigning different privileges to different users. For example, encoders will only have the ability to add data, but cannot delete or manipulate already existing data. GIS analysts, on the other hand, are permitted to make analysis and manipulate the data. This prevents unauthorized use of the data and makes sure that only the proper personnel can do certain operations on the data. A log is also kept showing which users did which operation on the data at which time and date. It is important when version tracking or identifying certain events or keeping backups of the data for certain time period. Network planning and optimization is another one of the main functions of GIS for telecommunications. Network planning in the GIS platform allows you to have a visual representation of the network and the factors you are considering. This is an intuitive way of doing the planning. The location of the spatial resources can be seen on the map together with the factors we are considering for the plan. In this sample, we can see the nodes of the network as well as signal coverage and the phone traffic in the area. These factors can be represented in a thematic map for better visualization. And analysis can also be shown on the map for intuitive review of the analysis results and easy understanding of its implications. Modeling and simulations can also be done for network planning. These kinds of analysis are helpful for tasks such as selecting the best resource location, studying the effects of terrain, and studying the effects of the new resources to the phone traffic in the area. Simulations and modeling are calculated representations of the real world, executed in the GIS environment to aid in decision making. This allows us to try out or simulate our planned solutions in the GIS environment first, so we can see the possible effects before going through with it in the real world. Another common analysis in telecommunications is the driver test analysis. So the driver test analysis involves a field team driving around in a car on a set route. And while driving, the team sends and receives a certain amount of data to make assessments regarding the quality of service. This results in a signal data set with spatial definition along the route traveled by the car. The driver test can be viewed and replayed in the GIS environment, and the parameters can also be viewed or changed to get more inference from the data. The data can also be related with the locations of nearby towers or other resources that may be contributing to the quality of service. Doing so adds context to the service quality values gathered on the field and gives information regarding the relationships of service quality with the existing spatial resources, the terrain of the area, and other factors that can be accounted for in the GIS environment. Frequency analysis is for the management of frequency resources in a neighborhood. GIS allows us to view these frequency resources on a map alongside existing observed frequencies in the area. Thematic maps can be made from the data to better illustrate what we want to see from the data. Viewing such data on the map gives us an intuitive view of the relationship between the frequency resources and the resulting frequencies in the neighborhood. This can further be analyzed to show the range of effect for each frequency resource, and analysis can be conducted for things such as the ideal new location for a new frequency resource in the area. Another analysis is transmission planning. This involves the use of viewsheds from terrain data to predict signal coverage from possible base point locations and planning the needed transmission lines for each selected location. The photos shown here show the predicted coverage of the planned base station, as well as the terrain data and planned transmission lines for it. GIS can also be used for market planning and analysis. Much like the previous GIS analysis we have introduced, we can also do analysis for marketing based on spatial and logical data sets. For this purpose, we would use data on population distribution, infrastructure, salaries, economic condition, age distribution, competitor location, and others. We can produce statistics describing the situation with GIS and come up with plans with GIS analysis and simulations. This is widely used in the telecommunications industry, where companies pay to survey competitor presence in neighborhoods and conduct house-to-house surveys to gauge telecommunications market in a certain area or neighborhood. The procurement of this data is crucial in making GIS studies and simulations that will closely mirror the actual situation in the real world. The selection of which data to involve as parameters in such studies is also important to make accurate and reasonable predictions of the market trends. So these are some of the specific types of analysis used in market planning. So we have market segmentation, revenue analysis, which is checking the sources of revenue, possible sources of revenue in the area and assessing them. Blind spot analysis, checking which parts of the neighborhood or area the service you're providing is unable to reach. Serviceability analysis, which is basically cost analysis for providing service in the area. And business intelligence analysis, which is basically a test of profitability of the area. All of these studies contribute to a good market planning and analysis of an area. These analyses use different types of data and provide different insights in the kind of service that can be distributed in a certain area and the profitability of doing so. Next, GIS solutions are also useful for the emergency services of telecommunications. The kinds of emergencies that we see wide use of in telecommunications are emergencies relating to public health, social security, catastrophes, and natural disasters. So for this, we are presenting the case of the use of GIS solutions in the Beijing Olympics. The main sources of data in this scenario is the phone traffic from existing base stations in the area and the data from the cameras deployed in the area. The base stations provide data about the quantity of data being sent or requested, as well as the quantity of messages being sent in the area, and other data regarding the use of telecommunications. The cameras, on the other hand, provide a real-time view of the area. Failure planning is the identification and location of a failure in a network resource in the event that a failure occurs. It is also one of the applications of GIS in telecommunications. It is usually easier to know that a failure has occurred and harder to locate the exact location of the failure. However, with the use of GIS, most of the time it is almost just as easy to locate the failure, since all the data describing the resources as well as their locations are already in the GIS system. So the system can easily be analyzed to identify the location of the failure. This greatly contributes to the next part of failure management, which will be to mend the failure and restore proper function of the resources. Often in the GIS system, the exact kind of response needed can also be identified, which further optimizes the response to the failure. The last GIS application that we will show you is something that is very close to us and something that most of us probably use quite often: location-based services. So location-based services are telecommunication services that take the location of the customer into account, usually through the location functions of a smartphone. We use this in automobile navigation, food delivery, identification of nearby facilities, and other such services. So at its core, this is a real-time GIS analysis using our location as the input. So, for example, in automobile navigation, it is a real-time optimal path analysis of a road network dataset with our current location and our selected destination as the inputs. Identification of nearby facilities, on the other hand, is a real-time spatial query with our location as the input, and the query being directed to a dataset of facilities held in a server. In these instances, our phones communicate our location to the app we are using. Then the app accesses the necessary data from a server based on a request made from our location. GIS analysis is then done in the GIS environment created by the data from the server and the data from our phones. So actually, we have GIS to thank the next time we have our food delivered or we ask our phone to give us directions. So, lastly, we would like to show you cases of SuperMap use for telecommunications. So the case that we will be showing you is for Guangdong Unicom in China. SuperMap provided them a unified map sharing platform which avoids the duplication of services and construction, as well as an integration of GIS service engine, spatial data, and business data, and an API for the unified sharing platform. So this is a map using the resources of Guangdong. And this is analysis results of service coverage of Guangdong. Well, this is the API developed for their sharing application. And this is another API that was made for their business functions. And that's all. Thank you very much.
Thank you so much, Ian. There we have it. He just showed us the overview and some demonstrations of the case solutions of SuperMap's solutions in the telecommunications industry. So there we have it. Our speakers just gave us a comprehensive introduction to what SuperMap GIS solutions can do for the telecommunications industry. And we hope that by this time, it is bringing you some new ideas on your current projects, research, or business. While the presentations were ongoing, our technical team has actually answered most of your questions already. But in case you would like to ask more, feel free to send us a message. And there are a few unanswered questions yet. So our technical team will just message you to answer that. So thank you so much for your curiosity. We hope that this webinar has sparked your interest on SuperMap, because we are happy to announce that we will be offering a free trial license to our participants here. Just send us a message or an email, as you can see on this slide. We have there our email address and our social media accounts. So to cap off our event for today, Let us hear some closing remarks from Sir Rafael de Maculangan, professor from the Center for Innovation and Entrepreneurship in the National University. Sir Rafi.
Hello guys, good afternoon. So wow, so SuperMap GIS is truly our future, right? So having heard about the key technologies like artificial intelligence, GIS, the big data GIS, the 3D GIS, distributed GIS, and cross-platform, and of course, as electronics engineering profession, so I believe this is a very useful tool in telecommunications. So have you think about in what kind of application you will apply the GIS? So if not, so if you want to hear more about the GIS, so you can ask our SuperMap technical support engineer. So in behalf of National University Center for Innovation and Entrepreneurship, I would like to thank all the participants, the NU community who have participated in this webinar. So I hope there will be more webinar in partnership with SuperMap and NU, and we will let you know. So that's the future schedule for webinar in the future. So once again, in behalf of NU Center for Innovation and Entrepreneurship, I would like to thank all of you, and of course, I'd like to thank the SuperMap for conducting this wonderful webinar. So thank you so much.
Thank you so much, Sir Rafi. We definitely hope to collaborate with you in the future. And thank you, everyone. We highly appreciate your attendance today. Again, feel free to visit the SuperMap website to get more information about the company. We also invite you to follow SuperMap GIS on Facebook, Twitter, and LinkedIn, as well as SuperMap Philippines on Facebook, because we are constantly posting about the latest GIS trends and what SuperMap is currently up to. For the students, again, we are inviting you to join SuperMap's first ever local GIS contest in the country, Agisan. You might also be interested to become one of our university ambassadors, wherein you will become part of the SuperMap team and you will represent your university. More benefits are indicated on our Facebook page, so make sure to like and follow SuperMap Philippines. Again, thank you for attending this webinar, everyone. I hope you have a great lunchtime. Don't forget to answer the evaluation form, which you can find in the chat box, so we can bring you a more improved webinar experience in the months to come. Expect your certificates in a few days via email. SuperMap will hold more webinars on more topics soon, and we hope to collaborate with your university next and more schools in the Philippines. So we will virtually see you soon in the next webinar. For now, goodbye and have a great week.